So there was a question asked earlier, what does a scientist actually look like? And I'm here with the bad news that this is sort of how it is. I wouldn't go very far in Bollywood, I think. So I'm going to tell you a story today about how fixed expectations can sometimes distort science, how images and public perception can really drive what we think about science. But mostly I'm going to talk a lot about Pluto and how Pluto was killed. And by killed, I mean, of course, that Pluto, as the planet that we all grew up with, is no longer a planet. Now, so I don't know actually how that played out here in India. In the United States, this was a very big deal. There were street protests. Seriously, we don't have serious things to protest about, so we have to protest about Pluto. I got hate mail. I actually got death threats, which is pretty amusing. But I'm actually curious. Was in India? Were people upset about Pluto? Did anybody hear about it? Is anybody still mad about it? Okay, there are a couple of people still mad about it. So for you, I just like to give you my alternate title, which is "The Pluto is Still Dead," and another good news. And if you're still mad about it at the end of the talk, then I encourage you to track me down and talk to me. I'm at Caltech, and it's right there. You can find it. So the story of why Pluto got demoted, got killed, really starts before the discovery of Pluto itself. It starts with the search for the mythical planet X. Back in the early part of the last century, astronomers had calculated, they thought, that there had to be another planet outside of Neptune, the eighth planet, the last planet. There had to be another planet outside of Neptune because they thought they had calculated that Neptune was being dragged along backwards in its orbit just a little bit by something else a little bit further away. And they thought, okay, if we can figure out what's dragging Neptune along and where it is, we can find the ninth planet. So astronomers sat down and did all their calculations. They went to a telescope that's actually right behind my house in Pasadena, California, up the hill a little bit. They took a picture of the sky right where they predicted this new planet X should be, and there it is. Do you guys see it? Oh, you don't see it. Okay, so this was the problem. They didn't see it either. They didn't see this planet because they were looking for something really large. If a planet sort of the size of Jupiter or Saturn had been in these pictures, it would be about this big. And you would just take a picture of the sky and you would know it was there. That was actually the way that Neptune itself was discovered. Astronomers had predicted where it should be based on its effect on Uranus. They went to the telescope, and the very first night searching for it, it was very obvious that they had discovered this eighth planet. Astronomers here looked, didn't see something, went back to the drawing board for a long time, and tried to refine where this planet was. In the meantime, a big search for this planet X was started in Flagstaff, Arizona, at the Lowell Observatory, and a young kid just off the farm in Illinois got hired to start searching the sky systematically, night after night after night, and he realized the only way he was going to find a planet was not by just taking a picture like this, but by taking a picture like this, taking one night later, and watching it move. I have to press these buttons. There. Did you guys see it move? Did you see the planet move? Okay, let's try again. Here's the first night. There's the second night. Anybody see it? Yeah, sure you did. Okay, let's try again. First night. Second night. Anybody? Anybody? Okay, I'm convinced this next time you'll all get it. I'm not sure why, but let's try it again. Here's the first night. And there it is, the second night. These are the discovery images of, at the time, the planet Pluto. This is how Clyde Tombaugh found them back in 1930. Here it is without the arrows on it. The problem was, I can't go. There. The problem was Clyde Tombaugh couldn't press the clicker. That's what. So the problem was that everybody knew what they were looking for. They knew they were looking for this massive planet that was pulling Neptune along in its orbit, but this thing that they found, Pluto, is tiny. It's so tiny I lose it. It's that one, right? Yeah, no? That one. That one. I don't know. I actually have lost it. It's so tiny that it looks like just every other star in the sky, and it shouldn't have. It was supposed to be massive. And so back in 1930, astronomers came up with some really good ideas on why it was so massive. 1930 was a very different time scientifically than 2011. In 1930, you could sort of make up crazy ideas that don't make any sense, and you could get away with it. Now it's harder to get away with it. My favorite idea that crazy astronomers made up in 1930 was that Pluto it's very massive. They knew it was very massive. And the reason it looks so small is because it's actually a core of solid uranium. This was 1930. They didn't know yet that that's a really, really bad idea. Core of solid uranium surrounded by a liquid oxygen ocean. And so that liquid oxygen ocean is very big. It's transparent, so you can't see the body. And not only that, it actually acts like a little lens, and it makes that uranium core even smaller. So when you look at Pluto over here, if you can remember which one it is, this one. It has a little tail. I can't even see it from here. Anyway, one of those guys is Pluto. When you look at that, all you're seeing is the uranium core, and you don't see the big liquid oxygen ocean. So when you leave today, the one thing I don't want you to remember is that Pluto is made out of a uranium core with a liquid oxygen ocean. Turns out that that's not just not true, that's actually crazy. There is no logical reason why anything anywhere in the entire universe should be made that way, but astronomers in 1930 weren't constrained by those same ideas. It turns out, in fact, there's a much better reason that we know of now why Pluto looks so small. Anybody know what the answer is? Because it is really small. It's actually a tiny, tiny little thing out there, and it is not the thing that was perturbing Neptune in the sky. In fact, when you go back to look at the data, there's nothing perturbing Neptune in the sky. Neptune is orbiting the sun just like it's supposed to. The discovery of Pluto in about the location that was predicted was a pure coincidence. And yet, that pure coincidence, compounded by the expectation that there was a massive object to be found out there, really convinced astronomers for decades that Pluto was this very large object. I was just looking at some of the old newspaper accounts of the discovery of Pluto, and there was one from the Chicago Tribune right after the discovery which said that Pluto is likely the size of Jupiter, and certainly at least the size of the Earth. They couldn't tell between the Earth and Jupiter, but it was one of those two extremes. And I'm going to show you in a minute how absurd that is, but it was just because of this very strong expectation that scientists had their ideas warped. It was actually a typical thing that can happen in science. I was actually reading the Emperor of All Maladies on the airplane over from the United States yesterday, the day before. And actually, one good thing about that book is that it's really long. And so if you have a 23-hour flight, it's actually just about right. But one of the things I was struck by is how the same ideas of how these fixed expectations of what's to be there affected the same way that scientists and clinicians were viewing cancer back in the 70s and the 60s. They knew what they were supposed to find, and when you know what you're supposed to find, you often find it, even when it's not there. So astronomers found this planet, even though it wasn't there. Let me show you how big Pluto really is. Everybody knows the answer to why Pluto's not a planet is because it's too small. But let me show you how small it really is. Here's the solar system. I'm going to show you this slide a couple of times, so let me walk you through it. These are the actual sizes of the actual planets. Here's Mercury, very small there, Venus, Earth, Mars, the large Jupiter here. Saturn, even without its rings, is quite a large object. Uranus and Neptune. If you look really carefully between Mars and Jupiter, you can see these tiny little dots. This is the Asteroid Belt, the very largest of the asteroids in the Asteroid Belt. You can just barely see in through there. In fact, these are all to size, and the only ones I show are the criterion for inclusion is you have to be at least as big as one PowerPoint pixel. So that's there are about 12 asteroids big enough in through there. And there, way down in the bottom corner, is the tiny, tiny Pluto. So let me just tell you one thing. It's not as big as Jupiter, and it's not even nearly as big as the Earth. It's this tiny, tiny thing out there, and it really doesn't fit the pattern of the other planets. If you were looking for something beyond Neptune and you conceptualized what you thought you might see, maybe you'll find something this big. That would be the natural progression. This one really didn't fit. And even when astronomers finally realized how small it was compared to all the other things out there, it was such an oddball out at the outer edge of the solar system that there was no good category to put it in. It doesn't fit in the category of the planets very well, and yet there's nothing else out there. So what should we call it? In the end, it was decided to keep it a planet for as much the reason that astronomers were looking for a planet in the first place as for the reason that it actually made any sense logically. Let me show you a reason why, starting in about 2000, astronomers really started to have questions about whether Pluto should be a planet or not. I'm going to show you now, instead of the sizes of the planets, I'm going to show you the orbits of the planets. And I'm only going to show you the giant planets now outside of Jupiter. Jupiter's here, Saturn, Uranus, Neptune, and each one of these little diamonds out through here is something in what we now call the Kuiper Belt. The Kuiper Belt is a band of material outside, mostly outside of Neptune, of objects that are just like Pluto. In fact, this little blue dot right there is Pluto. And if you look at the orbit of Pluto comes in, it kisses the orbit of Neptune in here. It goes out much further in through here. It doesn't look like the orbit of a planet, all those nice circular orbits of planets. And if I showed you the orbits of all of the rest of these objects that have now been found out in the Kuiper Belt, you would see the same thing. They're all tilted compared to the planets. They're all elongated compared to the planets. They simply don't look or behave like planets. They're much, much smaller than planets, and they're not on the same circular orbits as planets. This was a big problem for Pluto, starting, as I said, in about 2000, as the first several hundred of these were discovered by astronomers. And they're discovered in the same way that Clyde Tombaugh found Pluto. You take a picture of the sky, you come back a day later, maybe only an hour later, you take another picture of the sky, and you look for those things that move. Those things that move are the things in our solar system. Every single one of these little dots was found by some astronomer somewhere finding these things that moved. Starting in around 2000, astronomers started to say, hey, you know, Pluto really makes more sense classified as one of these things rather than classified as one of these giant planets or even a small planet out there. It starts to make more sense. The only thing Pluto had going for it back in 2000 was that it was still significantly larger than the largest of these other objects that had been found to date. I'm going to now fast forward through about 10 years of my life and just give you the punchline. But the punchline came with an intense survey that we did of the entire sky of the outer solar system, looking for these very biggest objects out there. And the one that finally dealt the death knell to Pluto was this one object that was actually not even in this region that we can see through here, but it was one much, much further away. In fact, it's the most distant object that humans have ever seen in the solar system. And I had the intense pleasure of being the first human to ever actually see it. This one morning, sitting in my office, looking at images that had come off the telescope the night before, looking through image after image after image, looking for things that moved, and I found this one object moving through the sky very, very slowly because it was so far away. My first reaction to this very slow movement was, I must have done something wrong. There are a million mistakes you can make. I must have made any number of those. I went back and I redid my calculations. Then I realized not only was it moving more slowly than anything we'd ever seen before, it was brighter than anything we'd ever seen before. Something that's further away than anything we'd ever seen, something that's brighter than anything we'd ever seen, had to be, I knew instantaneously, had to be the largest object that we'd ever found out there in the outer solar system. I did a quick calculation, and within 30 seconds I knew we had found something larger than Pluto. I called my wife Diane, who's out in the audience, so I said, I just found a planet. And I can't remember what she said. I'm sure she said something very nice to me, but it was an incredibly exciting moment. I went back, did all the calculations on it, we tracked down where it was. Let me show you some of the things that we found. First off, it's the furthest thing that anyone had ever seen. It is way out there. There was nothing else out by it. And my first reaction was, you know, if you want to find a planet, you look at this progression again, Jupiter, Saturn, Uranus, Neptune. If you wanted to put the next planet out there, this might be a good spot for it. You want to have a nice circular orbit around like this would be the spot. And so we desperately tried to learn as much as we could about it. What sort of orbit it has around the sun? How big is it? Is this actually the real 9th planet that we had been looking for? And the answer is no. This is actually just another object from this Kuiper belt. It actually has an orbit that comes in like this, back inside the Kuiper belt and comes back out. It's tilted from the plane. All the planets are in this one disk. All the other things are tilted. This one's tilted by about 45 degrees from where all the objects are, which is really unprecedented in this region out there. And the kicker is, we knew it was at least the size of Pluto, maybe substantially larger. We now know, as of actually last week, it is within about 10 kilometers of being exactly the same size as Pluto, which is a coincidence that's just a bizarre coincidence that the two largest things we know about there are so close to being the same size. Let me show you the best picture that I can of it. Here's a nice little portrait taken with the Hubble Space Telescope. It has, the name, oops, go back, there we go, back. The name of this object, you get to, whenever you discover these things out there, you get to name them. The name that we chose is Eris. Eris is the Greek goddess of discord and strife, which seemed a very appropriate name for the thing that eventually led to the demotion of Pluto. Has a moon around it. Actually, we were very excited to find a moon around it. Finding a moon around it leads many people to say, oh, it has a moon, it has to be a planet if it has a moon. But I then remind people that of those objects in the Kuiper belt, something like 1,000 of them have moons around them. Having a moon is a very common thing and doesn't make you a planet. And in fact, if you think about the planets, Mercury and Venus don't have moons around them at all, and they're planets, at least for now. So having a moon doesn't do anything, but it does let you do some very basic physics. It means that you can weigh the planet, the not planet. And what we learned from having this moon, Dysnomia, around it, Dysnomia is actually, it's named after my wife, but she doesn't like me to tell that story. Because it's the demon spirit of lawlessness, and she finds that embarrassing. It allows you to weigh Eris, and we now know that Eris, though it's the same size as Pluto, is actually 27% more massive than Pluto. So these two objects in the outer solar system would look so similar on the outside are actually very, very different objects on the inside. This is something that we are still struggling to explain scientifically, and we will struggle for a long time. I want to show you now my favorite slide of the instantaneous answer to the question of why Pluto is not a planet, and it looks sort of like this. Here's that picture again of the solar system. Here's Pluto in its tiny little, as the oddball at the edge of the solar system. And now I want to show you how much it's not an oddball at the edge of the solar system. Here are the objects that these are just the ones that I found over the past 10 years. Other astronomers have found many more, although mostly smaller ones. And maybe you can't quite see them, but there's a whole string of objects. There's Eris at the same size as Pluto. There are these crazy elongated ones. There are ones that are almost the size of Pluto. The whole region out there is filled with objects approaching and even exceeding the size of Pluto. Pluto, from going to be the oddball at the edge of the outer solar system, is now something we can actually make sense of. This is the way science finally progresses. We had this very wrong idea of what things were like. We classified things wrongly, and now we learn more. We can actually do the classification much better. People have often asked me when they ask me about Pluto and planets, and they say, you know, really, does it matter? Does it matter what we call Pluto? And in some ways, it really is just semantics. But the semantics is only the word planet. What it really is not semantics, it's classification. And I would argue that classification is the first and most important step in understanding, the first step in science. When you look at a group of objects that you've never seen before, your very first instinct is to try to put those into some sort of categories that make sense. And what I want you to remember from just staring at this slide is that the solar system does not consist of 9 planets that are sort of more or less the same, and then some other stuff. The solar system is really a beautiful and complex place, and that complexity is reflected in the categories when we categorize it. Here's the way I would categorize the solar system if I started from scratch. If I just arrived from another planet, from another star, I had never seen a planet, never seen the solar system before, and you presented me the sizes and the orbits of these bodies, I would say, hey, it looks to me like there are 4 sort of small things on circular orbits close into the sun. These 4 sort of small things are all rocky bodies. The terrestrial planets, Mercury, Venus, Earth, and Mars, all have solid surfaces you could walk around on. Then I would say, hey, but more importantly, it looks like there are these 4 really large objects that dominate the outer part of the solar system: Jupiter, Saturn, Uranus, and Neptune. And these are really the biggest, most important thing out there. And flitting between the terrestrial planets and the giant planets and flitting outside are these other objects, which by themselves are not individually important any more so than if you pick up a handful of sand, the individual grains are not important. But if you pick up a handful of sand and you analyze those grains in the sand, you can learn a tremendous amount about the area around you, about what's eroding, about the rivers that are bringing the material down in. This is the same reason that study of these things is incredibly important, even if none of the individuals matter quite as much. I'm going to skip my favorite part because I want to get to this one last slide. My favorite part here is the picture of my daughter's placemat, which is just, the point is, this is not what the solar system really looks like. This is the picture of the solar system that many people carry around in their minds. And the reason for that is because you see it on things like placemats. This is what my daughter eats her breakfast on every morning. She thinks that the planets are more or less the same size and that there are 9 more or less important things out there. And it's not true. It's not the way the solar system is. The solar system really is more like this. But the last thing I want to leave you with is this is not the solar system either. This is a good abstraction, a good way of looking at the solar system. But one of the reasons that I love our planetary system, that I love astronomy, that I love being able to study this is it's not abstract. These things are really out there. And I think most of us have lost sight of the fact that planets aren't pictures that come back from spacecraft or placemats that your daughter used. Planets are out there in the sky for all of us to see. When you guys go out tonight for dinner, I want you to try to see some of these planets. If it's a clear night, last night it wasn't, so you couldn't see them, but if it's a clear night tonight, right as the sun sets, you might get to see Mercury and Venus setting with the sun. If you're jet lagged like me and you stay up or you wake up really early, you might see Mars rising in the early morning sky. But most important of all, the one that you can see from anywhere is the brightest object in the sky is Jupiter, the giant planet Jupiter. Really one of the things that I think drove human understanding of our place in the universe more than anything else. Jupiter is rising to the east just as the night is falling. And as long as the clouds don't get in the way tonight, everyone should be able to see Jupiter. I often have people say to me, well, you know, I live in a bright city. I can't see these things. And I just want to explain to you that this is not true. And this is my best way to explain. This is from 6 weeks ago. 6 weeks ago, there was a very pretty conjunction of the full moon and of Jupiter. And here's a picture of it. There's the full moon, and there's Jupiter. Jupiter's right there. This was not an enhanced photo. I took a picture just like this 2 nights ago, standing in the exact same location with Jupiter right there, and with all the lights blaring of Delhi, with all the lights blaring of the Indian Gate right in your eye, Jupiter stands out like nothing else in the sky. So what I want you to do is something that I think most people don't do nearly enough of, and I want you to do it tonight. I want you to go outside, I want you to think about what's up there, and then I want you to look up and see the sky. Thank you very much.